Next topic is statistical inference. What is meant by inference? Inference is a process of making conclusions on something based upon certain facts. Now, in statistical inference also we are doing the same task, but here it is done based upon statistical data. So about what we are making inferences? In sampling distribution, we found that statistical population is a set of values collected from the individuals or items undergoing investigation on certain characteristic. Based upon these values of statistical population, we can formulate certain constants of the population. These statistical measures of population are called parameters, and these parameters are expressions involving entire observations of the population. Therefore, an investigator can make a lot of inferences based upon these measures of population and regarding this group of persons or individuals undergoing study. For example, in a village, if the proportion of houses having own toilet facilities was computed as 0.15, we can infer the living standards of the people living coming in that village. Likewise, if the average monthly income of a group of persons in a residential area is suppose 2 lakhs rupees or about 2 lakhs rupees, that information will bring out the lifestyle of the persons of that village. Therefore, these statistical parameters related to the population are certainly certain indicators which will give an idea about the performance of the group of persons or individuals undergoing investigation. Here, our aim is to determine the parameters of the population. So, in statistical inference, we are making inferences about the parameters of the population based upon samples drawn from that and also using statistical devices. To determine the population parameters, essentially we have to conduct a complete enumeration. But it is a very time consuming task. It requires a lot of energy, money, and effort, everything. Therefore, we have to draw certain samples from the population, and based upon the samples only, we are making inferences. So, we are not coming to a complete enumeration for computing the values of the parameters. That's why in statistical inference, we are making inferences about the parameters of population based upon samples drawn from that population. Now, statistical inference has mainly two branches. One is estimation of parameters, and second is testing of statistical hypothesis. In estimation of parameters, we are proposing certain estimates for the unknown parameters based upon samples drawn from that. But in testing of hypothesis, we will propose certain hypothetical values for the unknown parameter. And based upon certain samples drawn from that population, we will come to a decision whether this hypothetical value has to be accepted or rejected. So first we will consider estimation of parameters. In estimation of parameters, we have two methods. One is point estimation and the second is interval estimation. In point estimation, we suggest an estimate for this unknown parameter of the population. Suppose we have to determine a population parameter, say mu, that is population mean. So we draw a sample uh, from that population. Suppose the variables representing the sample are x1, x2, etc., xn. So based upon these variables representing sample, we will formulate a parameter. We will formulate a statistic, an estimator. An estimator is actually a statistic based upon the sample drawn from that population, which means that here we will propose a function of x1, x2, etc., xn to estimate the parameter. Statistic is a function of the sample, a measure of the sample, and Suppose sample mean we propose as an estimator of population mean. Then sample mean is a statistic, and that statistic is proposed as an estimator. Therefore, is sample mean is an estimator, and its value obtained from the sample is known as an estimate. So here we get a certain point or a certain value as an estimate of the population parameter. That's why this estimation method is known as point estimation. Here we are proposing a value through an estimator or a statistic they are composed of the samples x1, x2, etc., xn drawn from that population. But in interval estimation, there is slight difference. In interval estimation, based upon the sample drawn from the population, we will propose a set of limits, say T1 and T2, within which this unknown parameter will belong. That is, if x1, x2, etc., xn is a sample drawn from that population, that based upon that x1, x2, etc., xn, we will propose a set of limits or an interval t1, t2, and within which this parameter will be located. So there is slight difference in interval estimation and point estimation. In point estimation, we are proposing a value as an estimate of the parameter, but in interval estimation, we give a range of values bounded by an upper or lower limit, and this method is known as interval estimation. Next, we come to properties of estimators. Yes, in order to estimate a population parameter, first of all, we will draw a sample from that population. Suppose x1, x2, etc., xn represent the random variables representing x1, x2, etc., xn represent the random variables representing the units drawn to the sample from the population. For example, if you have to determine the proportion of electrified houses in a village, we will have a set of variables representing the response of the units of that investigation. So xi is the response of the ith house. Xi will be 1 if the house is electrified and xi is equal to 0 otherwise. Actually, when we come to the field, we will either record 1 or 0. But for formulation of principles, we are not making use of these ones and zeros. We are making use of variables representing these values of the responses. That is, we are making use of a set of variables x1, x2, etc., xn to formulate the principle of estimation. And when the sample first unit, when the first unit of the sample is electrified, then we will put x1 equal to 1, and if not electrified we will put 0. Therefore our formulation of principle is not based upon the ones and zeros connected to the sample, but it is based upon the variables x1, x2, etc., xn representing the units drawn to the sample. Now, after our investigation, we have a set of variables representing the zeros and ones. But these variables cannot propose any value as an any value for the estimator. We should make use of certain function of x1, x2, etc., xn. So as we found in that concept of a point estimation, we will propose an estimator. This estimator is actually a function of x1, x2, etc., xn, or it is a statistic. Okay, so based upon this x1, x2, etc., xn, we will propose a statistic, and that statistic is used as an estimator. And the value for that statistic or the estimator computed from that particular values of sample, it is an estimate. So the question is, which statistic has to be proposed for estimating the population parameter? We can propose sample proportion for estimating population proportion. We can propose some other measure of sample for also for estimating population proportion. Any measure of sample can be proposed to estimate a population parameter. So the issue is, which is the best estimator? Among the estimators proposed, which will estimate most accurately regarding the parameter? So there must be some criteria to identify the best estimator of a population. Therefore, Professor R. A. Fisher proposed certain properties, and the estimators which possess those properties can be treated as best estimate. And those properties are known as unbiasedness, consistency, and efficiency and sufficiency. So actually, therefore, the essentiality of introducing such properties are because we are limited with the information from sample. Based upon this information from sample only, we can estimate the parameters. So the issue is how to formulate this estimator. Every function of sample values can be proposed as an estimator. So sample mean is an estimator of population mean. Some other measure like sample median also can be proposed an estimator of population mean. Sample mode also can be proposed as an estimator of population mean, because we are in the situation of proposing any function as an estimator of population proportion, population mean or parameters. That's why it is necessary to introduce certain criteria to sideline the unfair estimators or to identify the best estimators. That's how we have certain properties, the desirable properties of best estimator, and those properties are our next topic of discussion.